once you find the critical points, to use that extreme value theorem, you're now going to evaluate the actual function at the critical points and the endpoints. So, take a look here. It says to use, now, the directions to the problems are going to look the same regardless of it's a closed or an open interval. So you have to decide what method to use. So here it says, use analytic methods to find, here's the keyword, the absolute maximum and the absolute minimum value of each function on the provided interval where they occur. So I've underlined the two terms that now should, you need to like be alert of: absolute maximum, absolute minimum. Now you look, is there a closed interval? Oh my gosh, there is a closed interval. So when we have absolute min and absolute max on a closed interval, these three together scream EVT. Okay? All right. So for EVT, we have to find the critical point. To find the critical point, what you have to do is you have to see exactly where f prime is 0 or f prime does not exist. That's the critical point. So we first have to find f prime of x, 3x squared minus 15x plus 12. Okay. Now I need to set this equal to 0. So I can factor out a 3. Four equal to 0. How does that factor? Yes. So now x is equal to 4, x is equal to 1. Now, these are the points where the derivative is equal to 0. So they qualify as critical points. Okay? Another way for you to find more critical points would be to see where the derivative is undefined. What is my derivative here? It's a nice, cute polynomial function. This is never undefined. So that point is moot. It doesn't even work. Okay? Now, these are my critical points. Now, also check. Are they within the interval?
Oh, yeah, they are.
Yes, they are. So we can use them. So now the next part is you have to evaluate f of 1, f of 4. Back in the day, the two ways to find critical points had different names. Like one was stationary points, one was, like, over the years we've like done away with that. So we all call them critical points. That's just a little FYI. If you're ever on Jeopardy, you can quote me. Okay. All right, so f of 1 and f of 4, and then I'm going to do f of 0 and f of 5. Why am I doing that? Because those are the endpoints. So what function, read the function that we're going to plug these into. X cubed, blah, 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 blah. So f of 1, wouldn't you know it is 5.5. No, I did not do that in my head. But we all know how to find that, right?
Plug it in.
Huh? Yeah, just plug it in, yep. F of 4 is negative 8. What's f of 0? That we can do, 0. F of 5 is negative 2.5. So now, what are these? We're saying when x is 1, the y value is 5.5. When x is 4, the y value is negative 8. So these are the y values, right? This is the lowest of the y values. So that's the absolute minimum. And this is the absolute maximum. Okay? How does that look? Okay. You all know how to do this. As soon as you, like, once you know what to do, you all know how to do it, right? It's remembering that this is what you have to do. So just remember, absolute min, absolute max, closed interval, EVT. It helps if you say it like 10 times before you go to bed. You know, it's like evening prayers. Huh? So you could just say, you could just like rewrite that. So absolute max, f of 1 is 5.5. Okay? The original, the x cubed minus blah, blah, blah. Okay, so here we go. Here's another one. Oh, now we have a fractional exponent, but it's okay. Okay? Same situation, closed interval, so we're going to do the same thing. So, all right, so f prime of x is equal to, the exponent comes down, x to the power of, and then we're going to subtract 1, right? Exactly, right? Instead of subtracting 1, I just wrote minus 3 over 3. So f prime of x is 2 over 3 x, and Sophie says this is negative 1/3. Then it goes on the bottom. So f prime of x, when you rewrite it, it's going to be 2 over 3 x to the 1/3. Okay? Another way to write that is this. So that's pretty much this. This is 3 cube root of x. That's what that is. Okay? That's what that is. So now, we have to check where the derivative is 0. When you have a fraction, right, when your function is in the form of a fraction, f prime is 0 means set the numerator equal to 0. Okay? F prime is undefined is code word for set the denominator equal to 0. Okay? So let's do that. Let's do that. Is f prime of x 0? No, because when you set 2 equals 0, that's meaningless. It doesn't give you anything. So like you don't get any information from that. So now, is f prime of x undefined?
Yeah.
At where? So you set the denominator equal to 0, right? And then, so you divide the 3, you have this, so how much is x? 0. So this is the critical point. This is where the derivative is undefined. Okay, so let's plug these in. Is that in the domain? Yes. So we're going to do f of 0, f of negative 1, f of 9. Okay, so what does f actually look like? This is the cube root of x squared. Okay, so let's plug this in. Cube root of 0 squared, 0. Cube root of negative 1 squared is what? 1. Okay, cube root of 9 squared is the cube root of 81. You guys know how to simplify that? Yes? No? Is it 3? How was it? Oh, so how would we do it? That would be 27.
Oh.
Huh? So how do we do it? Let's say it was like a different number. Cube root of 81. You do the factor tree. So this is what? 3 times 9 times 9. Okay. Cube root means you can group them by 3s and they come out as a single number. So 1, 2, 3, they get grouped and they come out as a 3. That poor thing can't leave, so it stays inside. So that's 3 cube root of 3. Okay, so minimum, maximum, right?
Wait, is it 3 cube root of 3 or just 2 root?
3 cube root of 3, because 1 3 came out. Okay?
Is it the absolute min or just the minimum?
Yes, the absolute min. I'm squaring them because it's the cube root of x squared, the original function. Okay? All right. So, okay, e to the negative x squared. So f prime of x, okay, okay, so f prime of x. You're going to take a derivative of an e. So the same thing just repeats, right? E to the negative x squared times the derivative of the exponent. So it becomes negative 2x. Okay, so now, okay, so where is this equal to 0? When x is 0. Okay, is everybody okay with that? Okay, is it ever undefined? Is there a number that when you plug into x, it doesn't work? No, so it's never undefined. So this is the only critical point. And it's in the domain, so let's go. So f of minus 1, f of 1, f of 0. So this is e to the negative 1 squared, e to the minus 1. Okay, what's e to the minus 1? It's 1 over e. Okay, so f of 1, e to the negative 1. So again, 1 over e. Oh, e to the negative 1 squared, but it's still the negative. So the negative is outside, right? So it's e to the negative 1 squared. And then f of 0 is e to the 0, which is 1. All right, so which of these is the biggest? 1. So we say, absolute max, f of 0 is 1, absolute min, yeah, both of them. No, because it's inside. Okay, questions? Okay, so next, it says to find the extreme values and where they occur. Okay, again, we need to look for extreme values, minimum and maximum. Does it say absolute? No. Is there a closed interval? No. So then we have to do the number line business. So again, you have to do f prime of x. Okay. All right. How does this factor? Yes. And now we're going to factor 3x and x. Are you guys all comfortable with factoring? Yeah. Okay. So it's going to be minus 4 plus 2. Okay. So when you set this equal to 0, x is 4/3 and negative 2. Okay. What's the domain of this original function? Right. Okay. And it's not undefined anywhere, right? So here, when I do this, I always write f prime, so I know where I'm plugging it into. Okay. Right. So now I'm going to plug in points into f prime. These two are good enough to plug in. I like to plug them into the factor form, into the parentheses, because it's so much easier, right? Okay, so here, let's say you have negative 10. Into this parenthesis, do you get a negative or a positive number? If it's negative in here, negative. In the second parenthesis, if it's negative 10, negative, right? Because it's got to be past negative 2. So negative makes positive, so this is positive. Okay, if I plug in 0, always do 0 when it's, in between a negative and a positive number. Negative, positive, negative. And then the other one is going to be positive. So that's f prime, okay? F prime is positive, means f is increasing, decreasing, increasing. So where is there a maximum and a minimum here? So we say maximum is f of -2, and then you're going to plug it into the original printed function, right? And you get 17. Minimum, f of 4/3, -1.519. Is this helping?
Yeah.
Do you guys remember any of this?
Yeah.
Okay, good. Because you did. I mean, on the final, it showed that you did. So, okay. That's the only benefit to not having the winter break be longer.
Do we think we plug it to the original thinking?
Yep. Okay. Okay. What's the domain of this one? Of this function, huh? Yeah. Yes, but then, yes, you're partly right. You're partly right. X has to be greater than 2, but then if X is too much greater than okay, so for the time being, you can graph this one. In the coming chapters, or lessons rather, you're going to know exactly how to do this, like by hand, how to graph this by hand. When you graph this, this is a semicircle with a radius of 2. So it goes from -2 to 2. Okay? So the domain is -2 to 2. Okay? Not yet. Now we're just doing the domain. Now we're going to find the derivative. For the derivative, it does help to rewrite it like this. Okay? Okay, so now let's find the derivative. This is a major chain rule problem. Half comes down. 4 minus x squared to the what? -1/2 times the derivative of the inside, -2x. Okay, now, this and this go away, the 2's. So now I have -x 4 minus x squared to the -1/2. So this is going to be -x over 4 minus x squared to the 1/2. We're cool with this? Okay, now, critical points. Where is f prime 0? Right, numerator equal to 0, so x is 0. Where is f prime undefined? The denominator, so 4 minus x squared to the 1/2 equal to 0. 4 minus x squared equal to 0. X is plus or minus 2. So those 3 are critical points. Plus 2, minus 2, and 0. Okay, now, okay, this is the domain, right? It starts at -2, it ends at 2, and then you've got the 0 here. But now, because, okay, the initial problem didn't give us endpoints, right? But now, when I looked at the domain, now I have endpoints. So because it has endpoints, we're also going to check the endpoints. Okay, but let's do the plugging in first. Okay, if I plug in, I'm going to do this one first. If I plug in a 1, right, into f prime, here's f prime, okay? If I plug in a 1, Look at the denominator. Will that be positive or negative? Just the denominator. So 4 minus 1 to the half. Will that be positive or negative in the denominator?
Positive.
Positive. And then the numerator?
Negative.
Negative. So the whole thing is negative. Okay. If I plug in a negative 1 into the denominator, it'll be 4 minus negative 1 squared. So positive, right?
Yeah.
How about here? If I plug in a negative 1? Positive, so this whole thing is positive. Okay, so let's just check the endpoints. F of 2, when you plug it in here, is 0. F of negative 2 is 0. So let's see what happens here. It increases, decreases. There is a maximum there. And then those two are minima, right? So there is a maximum, and this is an absolute maximum. F of 0 is what? 2. And then absolute min, F of 2 equals 0, F of negative 2 equals 0. Okay, so let's do the next page as well, and then the rest, the last page is like review of this, so I think this is good enough. Okay, mean value theorem. Okay, so mean value theorem, there were, okay, so a couple of things that I would like to stress. First, you have to check that the mean value theorem even applies before you can attempt the problem, right? Because if it doesn't, then you can't, and it's all wrong, right? So that's one thing. Some people had forgotten to do that on the final, and then so they found points for one of the problems that didn't have, it didn't qualify. So that's number one. So this one, let's see. On the interval 0 to 1, is there a point where the derivative, so to satisfy the mean value theorem, it has to be continuous and differentiable on the interval. So from 0 to 1, is this function continuous? Yes. Is it differentiable? So is there a corner or a vertical tangent or a cusp or a, no. Okay, so it satisfies. So now here's what we're going to do. You find the derivative. Remember, this is the formula you're going to use, right? So you have to find the left part, you have to find the right part independently, then set them equal to each other. So f prime of x is 2x plus 4. F prime of c, 2c plus 4. Okay, perfect. Now, let's find the second half, the right part. F of b minus f of a, that's f of 1 minus f of 0 over 1 minus 0. So f of 1, you plug 1 in here, and you get 1 plus 4 minus 3. Minus f of 0, you get negative 3 over 1. So this is 2 minus negative 3 over 1, 5. This is half the problem, okay? The formula says take this and set it equal to that. So now you have to take this and set it equal to that, okay? F prime equal to 5. So 2c plus 4, and then c is 1/2. Okay? Huh? It's a 5. Okay. Take a look at this one. On the interval 0 to 9, is this function continuous? Yep. Is it differentiable? No. There is a vertical tangent because it's a cube root. Okay? Cube root means vertical tangent. Where does the vertical tangent happen? You set the inside equal to 0, So at x equals 1. Is 1 inside your interval?
Yeah.
Yes. So since it is not differentiable on all points within the interval, you can't even apply the mean value theorem. So it's done, right? Okay? It's like if there was like a statement that had to do with a student going to D Toledo, right? Like if a student is a D Toledo student, then they're going to, I don't know, then they can go to Budapest in the spring, right? No, I said, okay, they can. Okay, so now, if I just find like some random person on the street who doesn't go to D Toledo, I can't just say, oh, that person's going to Budapest. Like, you see that? Like, it doesn't even apply to them for them to, okay? Okay, so, it's math. Everything in math is true. Yep, okay. So there's a joke. It's big with physics people. Anyway, okay. So it says it's actually very funny, but you have to be like in the physics world. 2 plus 2 equals 5, because we always talk about like if for large values of x, things change. For large values of y, things change. So the joke is 2 plus 2 equals 5 for large values of 2. Now, go tell Mr. Harris that, and he will totally laugh.
Will he give me like plus 2 on my like final something?
Maybe.
So?
Just tell him, Mr. Harris, I heard it. Yeah. 2 plus 2 equals 5 for large values of 2. Tell him that. Yeah, right, write it down. It is. It's actually really funny.
For the next test.
For large values of 2. Because you're always talking about, okay, for large values of x, this function will be undefined. Or for large values of x, then, this doesn't apply. Right, but the whole thing is like, okay, but because physics people always like, in physics, you always tend to like exaggerate a value in order to prove a point, right? And you're like, well, for large values of x, this will be true. And so the joke is like, for large values of 2, 2 plus 2 equals 5, but we all know that's not a thing. So. Okay. So, f prime of x is cosine. Oh, wait. Is this function continuous and differentiable everywhere? Yes, it is, because it's a sine. Okay. So, f prime of c is cosine of c. So, f of b minus f of a over b minus a. Now, this is sine of pi over 2 minus sine of 0 over pi over 2 minus 0. Okay, so sine of pi over 2, 1, minus 0 over pi over 2. So what is that 1 over pi over 2? What is that? 2 over pi. 1 over something means the reciprocal. Okay. Now comes the MVT part. Okay, this has to be equal to that. So cosine of c is equal to 2 over pi. So how much is c? C is inverse cosine of this. Put it in the calculator in radian mode, and you get 0.881. The one on the final was similar to this. People forgot that cosine of pi over 2 is 0. They said it was a 1, and then it kind of went on a tangent there. Okay, so here's where we're going to stop.